I hope you're having a great conference here. Thank you. So, my name is Bradley, and this is Lucas, and we're here to talk to you today about Gradle in Android Studio. We're part of a small team that is split across London and Mountain View, and we deal with the integration of Gradle into Android Studio. The name of the team is like Project System, Project Structure. We also support a few more things to do with how all the IDE works together. So the talk is titled Gradle in Android Studio 3.2 and beyond, but unfortunately that's already been deprecated. The real title should be Gradle in Android Studio 3.3 because nothing that we're going to cover today will be in 3.2, unfortunately. Okay, so what's the agenda? So first of all, we'll talk about in a bit more detail about what our team does and some of the challenges that we aim to solve. And then we'll go on to talk about what is Gradle Sync. You all may know it as that thing that takes a couple minutes, hours, where you can go and get coffee. But we'll tell you, why we actually need to do it and what benefits it has for you. And then you'll be glad to hear after that we're going to talk about some of the things we're doing to try and make it a bit faster, so you don't have to wait so long. And then we'll talk a bit about another project we've got going on, which is the project structure dialog. You may have used the one in Android Studio currently or in IntelliJ, and we aim to revamp the one we have in Android Studio because we feel like it's not providing as much value as it could. And then to finish off, we're going to talk a bit more about a couple of other things we have on our roadmap for the rest of the year and the coming years. So first of all, let me hand over to Lucas to tell you about what we do and explain Gradle Sync.
Hello, hello, hello. Do you want to use this? Mic work? Okay, so I hope it's not double mic'd. Okay, so thank you, Bradley, for the introduction, and thank you all for attending this talk. I'm glad to talk to you about what Gradle Sync is, exactly. So first thing, when I talk to people in conferences and in bars and in the life itself, I feel like they don't really understand what Android Studio is and what that thing Gradle is and how they go together and why do you need an SDK and how all of those things work together. And also, where is IntelliJ on the top of that? So just let me try to explain you a bit about how exactly it works. So what Android Studio is? Android Studio is an IDE, of course, which is built on top of IntelliJ. And we basically fork their code, and we provide a plugin for it called the Android plugin for IntelliJ. IntelliJ has other plugins that we also use, as the Gradle plugin and the VCS plugin and Kotlin plugin, which is an important one for now, that introduces the Kotlin support. And we upstream our code to them. So IntelliJ ships IntelliJ IDEA with our plugin, with their version of our plugin, and we ship Android Studio, which is our version of IntelliJ IDEA, with our plugin. That's Android Studio. And then, but basically, you don't need Android Studio for developing apps. You should be able to do everything with the Android SDK. We don't recommend that, of course, but you should be able to. So the SDK contains the basic tools, like build tools and ADB and libraries that you need and everything. And we built this nice integration between Android Studio and the SDK, where you can download components and see what is missing or not. You can see the newest versions and download it. And this is the SDK manager that has this interface with the Android SDK and provides you with everything you need for working, getting started. And then Gradle. What is Gradle? Gradle is a build system that basically does nothing by itself, Gradle. It's just a black box, and you can plug functionalities in it by adding plugins. There are a lot of custom plugins for Gradle, like the Java plugin, and there are plugins provided by other companies, Kotlin plugin. And you probably can build your own plugin if you need to. And we have this Android plugin for Gradle, which wraps all the functionalities that we need for building Android code and doing other stuff with Android. So you don't have to deal with the tools in the SDK directly. But actually, the Android plugin will have all of that logic for you. And you are able, for example, for just run Android Gradle assemble. And this will deal with all the tools and assemble everything for you. So that's the main idea behind the thing. And then how Android Studio and Gradle communicates. Gradle provides this thing called tooling API, which is basically a way to programmatically insert Gradle functionalities in your Java code or other code. So basically, it's a bunch of libraries, entry points for in Java, and you can add that to your application, in this case, to Android Studio. The problem is, so the other way to do that would be you run Gradle in a separate process, in a separate VM, and parse the output. But the problem with the output, parsing output, is that it's not consistent from one version to the other, etc. So they provide this tooling API, which provides structured data, and we can consume that from the IDE. But the problem of that, and I'll talk a bit more about that later, is that bottlenecks in the tooling API might happen, and then bottlenecks in our communication with Gradle might happen with that, because of that. And that limits what we can do to improve things in general in Android Studio. So I hope that gives you a better understanding of what's all of that and how it just magically works sometimes. And what does our team do? We are basically responsible for the ROs. We make the integration between things, and we try to do that as smooth as possible. Maybe it's not always like we wanted, but basically we are responsible for syncing a project with Gradle Sync, and then building the project when you just click in the IDE and everything works, or should, and running unit and Android tests inside the IDE by right-clicking classes or methods and or packages, and then we figure out the class path you need, and we run and we show results. And also the project structure dialog, which Bradley will talk a bit more about that later, and some other bits of Gradle in the IDE. So basically, we are responsible for trying to make a smooth integration between Gradle and figure out that, and try to make as it was not there for you. But sometimes it's still, we can still notice it's there. Okay, so what is Gradle Sync, and why do we need that? It's just a bar that keeps running slowly and keeps you busy while you are doing other things. But no, actually, there's a reason why we need that. And the reason is, in the very beginning of Android Studio, we decided that Gradle is the source of truth of your project, which means, which has a big benefit of preventing you from making configuration files twice. If you have a dependency or anything about your project, you just have to put that in the Gradle file, in the build file, and not in the IML. And we will try to translate all of that structure from build files and the setting files and all of that Gradle configuration to IMLs, and make IntelliJ works with that, IntelliJ, which is Android Studio plus things. So that's why we need this Gradle sync. Without that, basically nothing would work. We wouldn't know about where the source sets are and what are dependencies, and we wouldn't have code completion. We wouldn't have highlighting, resolving symbols, etc. So it's basically necessary for all the other features in Android Studio if you want to keep those properties of having only one configuration place. And we kind of do want that, because also that should mean consistency between command line when you run through Gradle and when you run from the IDE, and in your in your continuous integration server. If everything is consistent, it's much better for every pipeline I might think about. So what is it? It's basically, we get the structure of the project from Gradle in a kind of smart way, trying to build models that that mean something for us, and we configure the IDE with that. What is there in those models, in this project structure? Basically, everything you need to have an IDE. Source sets and dependencies, and build tools versions, and all of those things that you put in the DSL, they are there. And we try to make sense from that and configure the IDE and make it available for other features in the IDE. And how does it work? I'll try to give an overview of how it works, so you might understand why, when something failed, where it failed, and try to figure out what's the problem. So basically, the first step is we see that there's nothing, everything necessary for running is there. Basically, we check that we have JDK and SDK. This is in the pre-sync checks. And then we clean up the project because since the structure comes from Gradle, we are never sure to have it up to date in the IDE. So when you make a sync, we just delete the entire project structure. Of course, we don't delete the downloaded dependencies and stuff like that. But we reconstruct the entire project structure. So we delete everything. We create for you a Gradle wrapper if you need that in your project. We configure proxies, and we set up the JDK to launch the Gradle daemon in a separate VM, of course. And then we connect to Gradle through this tooling API. We have this cool thing called build action that Gradle introduced some time ago, which is basically a piece of code that we can give to Gradle, and it will be running Gradle VM inside Gradle, and it has access to all the things that the Gradle plugins can provide. So basically, inside this build action, you can ask, give me a model called this. And then Gradle will ask each one of the plugins, can you provide a model like this? Can you provide a model like this? And if one of those can, it will just return to you this model. And why do we need a build action instead of a piece of code to run inside instead of just asking the model directly? Because Gradle has this thing called, this thing which is, each module in IntelliJ is a project in Gradle. And they are independent. So you can ask a model for one project, but we don't want to call Gradle once for each module. We want to have all the models that we need together at the same time. And also we have other models, not only Android model. We have Kotlin models and Java models and C++, etc. So this build action was a nice thing that they introduced a long time ago in 1.2, I think. When we are able to, and now we are able to just get everything we need in a single invocation. Not really, I'll talk about that later, but almost. And then we get that model back, and we configure the IDE. And if we know that if you are reopening the project, we just load everything from cache instead of loading the project, the model again from Gradle. Cool. And of course, I think you all agree with me that Gradle sync is super, super fast. Or maybe not all of you, but I'm sure that someone maybe. And we know that it's not great, it's not super fast, and we are trying to improve the performance. We have some cool projects coming that are being developed for some time. And I want to show you that, but before, just to explain a bit why it's kind of difficult to make improvements in this area. First, we are a small team, as Bradley said. And then we are in the middle of 3 companies, right? We are in the middle of Google, IntelliJ, and Gradle itself. So bottlenecks in Gradle tooling API means bottlenecks in sync, and lack of models in IntelliJ means lack of models in our sync. And the sync infrastructure that IntelliJ provides in its Gradle plugin means that we have to use that if you want to keep support for IntelliJ and not only Android Studio. So we have to coordinate all of that work, and it's not always easy because of release cycles and different paths that enterprises want to, that the companies want to follow. But we are making good progress on that, and we hope to have some cool things soon, like single variant sync, for example. So this is, because of limitations in IntelliJ itself, we can only use one variant at a time. So even if you have multiple variants, only one of them is used at a time in IntelliJ, and you can't access the other source codes, etc., only by changing the build variant, but then the other one is selected, not the previous one. So, but the problem is that Gradle syncs all the variants, and that means that all the models for each one of the variants and all the dependencies are resolved more than once because of that. And the question is, why don't we just sync one variant? And we thought about that a long time ago, and we didn't implement that before because that depends on being able to pass parameters to say to the tooling API, I want this model, but only for this variant, and other stuff like that. So we contributed to Gradle some time ago, and in Gradle, since Gradle 4.4, now we are fortunately able to pass these parameters that we need to sync only one of the variants. And we have, I'm happy to announce actually that we have this end-to-end sync functional, only one variant for Java projects, and we are working with IntelliJ to extend to Kotlin projects soon. And the results look pretty good. Basically, we have a constant time always because of configuration time in Gradle and invoking the daemon. I'll talk about that later. But except by that, dependency resolution is the part that spends the most time. And we are now just resolving dependencies for one of the variants. So if you have like 6, 7, 8 variants, it should be much faster for you. Most of you have at least 2 variants, probably debug and release. And then if you have paid and free and 2 other flavors, it means that you have already like 8 or 16 variants, and that should help you for sure. Cool, so that's the variant sync. It's implemented in, it will probably be released in 3.3 first canaries. So I'm waiting for your feedback if you want to try that. And then we have another project, ongoing project, which is the single invocation sync. So first, let me explain how sync really works. We have 2 steps. One step is about syncing, really getting the models. And the second step is about generating sources. Nothing in the IDE would work without generating sources because you need the R class and you need the exploded AERs to be able to search code, etc. So those 2 steps, the first one is done like this. We fetch the model by Android Studio, use the tooling API to connect to Gradle, and then it asks the model to the plugin, and the model is returned. And generating sources, it's pretty much the same. Android Studio uses the tooling API to connect to Gradle and then schedule tasks to be run. But we still have to invoke Gradle twice because the tooling API doesn't provide us a way to first fetch a model and then run tasks because our tasks name depend on the module we got. So we've worked with Gradle for the last few months, and we introduced a new support for tooling API, in the tooling API to run those new phased actions that we introduced, where you can basically put code between 2 steps of the build. And then now we can schedule tasks after fetching model, and we are able to invoke Gradle only once. What does it really mean? It means that we are avoiding configuration and resolving dependencies twice. Gradle basically works like this. It first starts the daemon if it's not started, and then it initializes the project. And then it runs all the Gradle scripts that we have. And that's why you should not put a lot of logic in these Gradle scripts directly in configuration time. This is configuration time when it runs all the scripts. And we can't avoid that. We can't get anything. We can't get a model or run tasks before that. So there's always this fixed cost of configuring the project. And we can't really fix that for now. And that's why actually when you build directly from IntelliJ using JPS, for example, it's faster because we have a file watcher watching the files and seeing what changed and refreshing the structure of the project. While Gradle, each time you run something, it will check all the files, configures the project, and then execute something. So we are trying to avoid all of those constant things by invoking Gradle only once. And I'm happy to announce also that the pull request we sent to Gradle is already accepted and merged. And it will be released in 4.8, and we are able to implement that now. That should also be in Canaries 3.3. Cool, and as a last improvement in sync that we are working now, which should help a lot of people with a lot of modules. I don't know if it's many of you, but basically when you have a lot of modules and you don't work with all of them, which happens, for example, in huge projects that you only work with 3 or 4 modules, you shouldn't need to sync and load all the modules and put all of that in memory if you're not using. And that spends a lot of memory in the, so that's a project that that IntelliJ also wants to have it. So basically you would be able to choose the modules you work on, which is fine for your day-to-day work because you don't need everything. And then the other modules that those depend on would be replaced by a binary representation, a jar with your sources and your classes. So you would still get, of course, highlighting and code completion, etc. And the other modules that have nothing to do with those, it would just not be loaded. Then sync would be much faster. The binary representation is lighter, so we wouldn't need to sync all the time all the modules, but only the few ones that you work with. And that would be very useful for big projects, saving memory, sync time, and even processing. So that's something we are working on, and we have already the APIs we need for that. And now it's a matter of implementing in Studio, which should, I don't know, I can't make more promise about 3.3, but it will be there soon. So now I pass back to Bradley to talk about the project structures dialog, which will help you a bit also.
Yes. Hello? Yeah. Thank you, Lucas. So another pain point we have with the current integration with Gradle and Android Studio is there's no easy way for you to view everything to do with your project. So just a show of hands here, who actually has used the Android Studio project structure dialog in its current form? Okay, so not too many people. We want to try and get that number up, and we want to allow it to provide you with more value. So with the new revamp of the project structure dialog, we want to focus on two main goals. The first one is we want you to be able to visualize your resolve structure of your project. So this means a full dependency graph, how your build variants are made of your product flavors and your build types, and also provide you with ways of keeping your project up to date and also helping you maintain your project. The secondary goal is we want it to be able to help you in editing your build files. So if you want to change one of the properties in your build files, you'll be able to go to the project structure dialog and edit a text edit in there, and then you'll see changes reflected in your build file. And this allows us to constrain what kinds of things you can put in there, which will mean that the chance of your sync failing because of a typo or something like that will decrease. There is a big caveat with this goal, though, and that is the way the project structure dialog will work is it will take two sources of information. The first source will be from what Lucas was talking about, the resolve models we get back from the sync. And then the second source will be a parse of your build files. If you're using very complex, well, not even very complex scripting, but scripting in your build files, then we won't be able to correctly parse it because Gradle provides very flexible interfaces, and without running the scripts, we can't work out which values go where. But if you're just using basic properties and basic types, we should be fine. So this is an example of what the UI should look like. I apologize for how big it is on this projector, but hopefully you can make out the different parts. So this is the dependencies view. But before we start on that, let's go and have a look at what kind of things you can expect from this new dialog. So firstly, we'll have information about your project, SDK location and version, same for JDK and NDK. Variables. So I'll go into this in more detail later, but basically the whole project structure dialog will support the use of variables in any of the fields. And these are either Groovy variables or properties on Gradle's extra properties extension. Then we also have information about modules, dependencies, which we'll cover in a second, flavors and build types, sign-in configs, and then suggestions, which we'll also go over later. So now, if we take a look at the center of this panel, you can see all of your dependencies that we've managed to obtain from your build file. So these include the scope it was configured with and the Gradle coordinate for the artifact. From here, you can also add and remove dependencies. A nice thing we can also help you with when adding dependencies is because we're parsing your build file, we also know which repositories you have declared, so be that JCenter or Maven Central or any other repositories, and we can try and help search them for you. So say if you wanted to add a dependency, say Guava, to your project, you could go in here, type in Guava into the search, and then see a list of all the artifacts with the name Guava, and then pick whichever one you want, be that by group ID or version. And this also helps you, when you're adding a dependency, to make sure you get the latest version that is available on your repositories. And then below this, we have a panel where you can edit the version of your selected dependencies. Again, this can help you get to the latest version. We can also suggest all available versions, so there's no, if you want to upgrade or a dependency, you're not guessing which version comes next. You will already be able to select and see all the versions from the drop-down. And then on the right, we have a panel which shows all of your resolved dependencies. So this will be a full dependency graph for your project. So on the top nodes, you can see we have the different build variants. And then under that, we have what they depend upon. You can expand this further to get your transitive dependencies and keep going until you can see everything that your project will bring in at build time. So next, let's move to the suggestions view. So on this view, we wanted to bring together all the information that we know about your project and help provide actionable things for you to do to upgrade your project, to fix issues, and just give you information that we think you might find useful. So the kind of things that we're going to show here will be, we have 3 examples here. So let's go to the first one, which is conflicts. So if Gradle detects that you have an unresolvable conflict, we can flag it here and tell you which versions are conflicting, which libraries are pulling them in, and also which artifact is the actual thing that is conflicting. Updates, so in order for you to keep your project up to date with all the dependencies or the Android Gradle plugin or things like that, we can show you whenever a new version is available, and then you can have a quick action to update, which will, again, go to your build file and change the value there. And then finally, we have information. So the type of things we want to show here are just helpful things that you may need to know, you may not need to know, and then you can dismiss them. But so for the example we have here, it's Gradle has promoted a library. So you probably know what this means. It's when 2 libraries require the same dependency, and Gradle picks the highest version to use. This is in contrast to a conflict where in a conflict, Gradle can't match the dependencies together, whereas when a library gets promoted, it can do that. So the next thing is flavors and build types. So here we'll list all your build types and product flavors. So this is a rather simple project with just debug and release build types. And you can see underneath we have all the different properties and attributes that you normally find in your Gradle file. So you may notice here that there are different visual cues on some of the fields. So let me just go over what these are. So the first one is if you see any of the values in blue, that means that those values are obtained by using variables, which again we'll cover in a minute. But every text field on the PSD will support the use of variables. By PSD, I mean project structure dialog, if you didn't get that. The second one is when the value is strike through with a line. And what this means is, the value we get from Gradle sync is different to the value we find in your build file. So this can happen for 2 reasons. Either it's overwritten in a later stage of the build or the configuration, or you've already changed it in the dialog. So this will help you, if you write some value to your build file and then you're wondering, like, why is this not what you think it should be? This will tell you the resolve value and also the value that we found in your file. And then to the right, we have the resulting build variants. So these will be a combination of your product flavors and your build types. And then we'll list information for each of those build variants, how they're resolved. And then, again, with the values that come from variables, you can hover over them to see which variables actually being used here. So a good case for these variables is the support version libraries, where the support library versions, where each one must match. So you'll create a variable for these, put them there, and then to update them, you just need to go and update the variable. You don't need to go around and update each of the dependencies individually. And just an aside, it's common for for you to want to extract out things that are common in the build files. So we also support apply from. So if you have your dependency versions in a separate file or some config that's common throughout your build files, we'll be able to detect that as long as you don't pull it in some groovy magic. So if you just use a basic apply from, then it should be fine and we should be able to detect those. So the variables tab. So this will allow you to see everything that's been pulled in, all the variables. As I said earlier, there's two types of variables we recognize. Here you can create and delete variables as you want, and you can also see the value and the resolve value of those variables. So for example, the foo variable here, I think that's a v, which means it's a groovy variable, has the value bar, which is in blue, and that means it's another variable. And you can see the resolve value is different because it's pulled up from somewhere else. This is just an example, however, because you may notice that bar is actually not that value. So this is a UI demo. It's not functionally correct. But hopefully the thing we build will be functionally correct and you won't have that in your build files. And then we also use all these variables in the autocomplete. So if you're entering a value in any of the fields on the PSD and you enter a $, we will then suggest variables that you have defined in your file that match the type that we expect. And again, you can write lots of other things to your build file, or you can put garbage in these fields, and then we will write garbage to your build file. So that's not advisable. So hopefully this will help you not only view your project, but also enable you to quickly edit and change different properties in your build, and also support the common patterns that people use in build files. So if you have any suggestions about other things you might like to see here, please let me know after the talk, and I will let Lucas finish up with a few other things, and then we'll go over to questions.
Cool. So thanks for the PSD, which is PSD basically will help a lot with understanding what your project structure and trying to change that in a simple way. Mainly if you are not used to work with build files, etc. Where's the thing?
Apologies.
So yeah, some other projects that we still have in mind, and we are planning to have them for the future. So these are some of the most requested features by the users about this area. First one is that when you run tasks through the IDE, through Android Studio, you not necessarily get the same results as if you run through Gradle. And we want to change that, of course, because that's one of our axioms in the beginning when we first chose Gradle. And the reason because it's happening is that we don't use Gradle to run the tests, but we just generate the APK and then we upload. Well, Android Studio itself uploads the APK to the device and uses ADB to run the tests and parse the result. And the reason why we do that instead of using Gradle is that Gradle tuning API, again, still doesn't support very well those test events and choose the test task. So we are also working with them, and once we get that in Gradle, we can implement in the IDE, hoping to have that soon. And another improvement that we want to make soon is when you sync a project and you get the message saying that one of your SDK components is missing, then you still sync again and you get a message that another component is missing, etc. So you want basically, if possible, just download everything within Gradle and then you don't have to worry about that. And if not, just to show all the errors at the same time, and you can quick fix them at the same time and make sync fast. So these are some ideas. And just as a hope for the future, what we really want to have in this team is remove the need of manual sync. So basically, it would be great when you are just changing the build file, you have the new structure, as it kind of works in JPS and IDEs usually. So the problem with that, first, it's impossible to do that now because Gradle doesn't work that way. Gradle, each time you invoke or you want a model, it has to configure the project and start a demo, etc. So we are thinking about solutions for that, like keeping a demo dedicated to Android Studio, which would have file watchers and see and have the project structure up to date, so you can just query for models or run tasks immediately. And that would remove. And also, we would need a parser, something understanding what part of the Gradle file you are changing, and then you are able to just sync part of the model. So these are some problems that are still unsolved. We are trying to solve. So if you have ideas or comments or want to discuss that, just come to us after. And with that, I'm happy to take your questions if you have some.
Hey, thanks for the talk. I really love the dependency graph, which is embedded inside the structured dialog. Question is, if for some reason I move all my Gradle files to Kotlin script or something, I mean, something you cannot parse, is this information coming from Gradle itself, or is it something you parse yourself? And the question behind that is, are you going to suggest new versions if you cannot parse the build scripts? I don't know if it makes any sense.
Yeah, so the resolved dependency graph is obtained from Gradle, so even if we can't parse your build files, you'll still get that. The thing that won't work if we can't parse your build files will be the editing of the versions and the adding and removing. We should still be able to surface information telling you that this dependency is out of date, but we won't be able to help you edit it.
Any other question?
Thanks for the talk. It was very interesting. Will it be possible to import library version 5? For example, we have in our project a WAV file with all the version of our libraries because it's convenient between our models. We can be sure to have exactly the same version. Will it be possible to import it?
So do you mean you have the versions in a separate Gradle file?
Exactly.
If you have them as Groovy variables or part of the Gradle's extra extension module, then we will find them and you will be able to edit them as well, yeah.
Great, thanks.
Questions? I think there's one there.
Hey, I have a question with the Android 3.2 and 3.3. With the project structure dialog, is there a way to filter a variant such as just the debug or release? Is there a way to do it with project structure dialog, or we need to configure Gradle to filter a variant build type?
Currently, I don't think we are fully decided on the exact things. So we'll keep that in mind, and hopefully you'll see that as well. Yeah.
Thank you for your talk about code coverage. It isn't very well supported for instrumented tests. And when your code is written in Kotlin, I'm not sure it's working very well. Any plan to improve that?
Yes, yes, there are two things there. One simple improvement we could do is just to fix that covert support for Kotlin. But what we really want to do in the long term, not long, but medium term, is to run the tests, as I said, by Gradle, using Gradle tooling API, and then we can have multiple features improvement, since we can even have like test reports and coverage reports and everything that is produced by Gradle directly, and then we just invoke that each time we run by IntelliJ and we parse that results back. So yes, that's in the plan for soon. We are working with Gradle to improve the tooling API, and then we can implement that.
Hello, thank you for the talk. I think all the feature coming up is really inspiring. I have a question on ProGuard and R8. First one is, do you think R8 will be released, will be shipped with 3.3 as not experimental?
So the answer is, I don't know.
Okay.
I'm not working on that part. Probably some people here know. You can come to ask to me later and I can ask them.
Okay, sure. The second question is, we use a lot of plugins such as Sonar or Jacoco, something like that. Do you guys planning support like maybe third-party plugin integration with Android project?
So you mean plugins for Gradle or plugins for?
Plugins for Gradle, like, because
yes.
currently we're adding a lot of properties in Gradle properties. I don't know if there's further.
Yeah, so there's a fundamental problem with that, which is we don't know which plugins you will apply, and each one of these plugins would need to provide models so we can really understand them and they don't break us. So that's the basic problem with Kotlin now. Kotlin doesn't have, the Kotlin plugin for Gradle doesn't have specific models, doesn't have models well defined. So they can just change APIs at any time and that would break us. So we have to work with them for produce models that are stable, and then we can consume them. Our first priority is Kotlin, of course, but we are also planning to extend that for other plugins. The thing is that it's also it's always a huge work to work with them to produce models so we can consume, etc. But it's on the go.
Thank you very much.
Okay, thank you very much.